Hello everyone, my name is Riley Dickens and I'm a security consultant with Encryption Consulting. So today's video we'll be talking about a wildcard search, what it is and how you can use a wildcard search on actually tokenized data. So let's start with what a wildcard search actually is. And for that we can use an example which is used in Linux. So when you're using Linux, you might come across something that looks like this, a command that is cp and then the file path. So for here we'll use home and then a slash and then say file asterisk dot asterisk. So this right here is an example of a wildcard search. So what this is saying is that it wants to copy over a file, any file in this home directory that begins with this file, F-I-L-E. It doesn't have to be file, it could be fillet or something like that, but as long as it starts with F-I-L-E, anything after that can be there, as well as any extension. So a wildcard search kind of uses the first couple of letters or one letter to search, say, a database or a file system, and it just needs to specify that first letter or that first phrase. So another example is, say you're using the command ls and you want to see what's in a directory, and you just want to find all the files that have the letter D at the beginning. So this is how you would do it. This will search through this home directory and tell you every single file that starts with a capital D. So this is what a wildcard search is. So now we'll move into how you could actually use a wildcard search to search a tokenized database without actually having to reveal that data to a user. So for our example, we'll talk about how a user would use an application which can see the clear text last names of a table of data and would work with an encryption platform that would work and find the tokenized data within a tokenized database. So here we have our tokenized database, and let's say that the different columns are first name, last name, and social security number. So all of these values in this database are tokenized, so they're not actually what they should be. Now the user would connect to an application, and that application will have access to a clear text table. So that table, let's say, will have the last names all in clear text. So what happens is the user connects to that application and says, I want to find all the last names that begin with D in that table. Now the data that will come back to the user in the end will be tokenized. But how would you go about that using a wildcard search? To begin, the application will send out a query to that clear text table of last names. And that query will look like this. So this query right here will tell the clear text database, okay, I want to find everything, which is what this star is, from the last column or the last name column in that clear text database, where that last name looks like this, and this is where the wildcard search comes in. So this percent acts like that asterisk did in the Linux command. So it's saying that it wants to find all the last names that are like this, where this is starting with a D and anything else after it. So let's say that database comes back with Dickens and Derrickson. So now that the application has gotten those clear text last names, it will send those last names off to the encryption platform. And that encryption platform will tokenize these values. So let's say Dickens gets transferred to LAUV and Derrickson gets transferred to CID. And so now these values are what they would look like when they're tokenized. So the application will now send out a new query to the tokenized database, and it will use these tokenized names instead of the D%. So here's what that would look like. So similarly to the original query, this one is now saying select everything from this tokenized database where the last name column is either LAUV, which we know translates to Dickens, or last name is equal to CID, which we know translates to Derrickson. So now that wildcard search has found all those names that have a last name that starts with a D, and they can return all the values of those names in tokenized form to the user. So now the user will get a tokenized first name, this LAUV, which we know stands for Dickens, and a tokenized social security number, and it can use that data for any computations it needs. Now, if that user has actual access to that data and can actually detokenize it, it can then send a secondary query and get the detokenized version. But this is really for anyone that might need the data just to work on data that doesn't actually need the real values or doesn't have access to those real values. So now you've seen how a wildcard search can work with tokenized data. Thank you for watching today. If you have any questions about wildcard searches or encryption in general, please visit our website at www.encryptionconsulting.com. Thank you.